Hi everyone, we're going to find the domain, locate any intercepts, and graph our function, and find the range based on this graph. We're also going to test for continuity and also evaluate it here. The first thing we're going to do is, before we get started, let's just look at the domain. This is your domain portion. This is your range portion, or your y. This is your x portion. And we can see the domain right away from this. We're starting at -2, and then we're going from down here, x is greater than or equal to 0, so this goes to infinity here. So our domain is going to be -2 to infinity. And we can knock that out right away. So let's go ahead and test for continuity. And when you test for continuity, you must meet these three conditions. That's the definition of continuity. And the first thing to notice is we're testing at x equals 0. Because basically this is where the graph is changing. And it's changing three places at the 0 point. So our c equals 0. So we're going to test our first condition, f of 0. Now we have to plug it in this second portion here, the middle portion. So when x equals 0, our y is 1. So it does exist, so condition 1 is satisfied. Now for our second condition, we have to check for limits. So that means the limit as x approaches our c, which is 0 from the left of our function, of our graph, should equal the limit as x approaches 0 from the right of our graph. And if you look at it, just the line here, so this is our 0. So what's from the left of 0 is all, these are the numbers that are negative. So these are all numbers that are less than 0. And then as we approach 0 from the right, if you look at 0 here, this means all numbers that are greater than 0. What's going on with the graph as we get closer and closer to 0. So to take this limit from the left, we're looking at numbers less than 0. So you plug in 0 in here, and absolute value of 0 is just 0. Now we want to know what's going on from the right. That means all numbers greater than 0. So you plug in 0 into this equation, and you get 0. So 0 does equal 0. So condition 2 is met. That means the limit as x approaches 0 is 0 of f of x equals 0. So now our third condition means the limit as x approaches 0 of f of x should equal our f of c. So this part equals 0. So that's 0. And this part equals 1, because we already did that. They do not equal. So that means condition 3 fails, and that means this function is not continuous, or it's discontinuous. And then when we graph it, we can really see what's going on. So let's go ahead and graph it. So I'm going to start at 0 and plot this first part at 0. So we already know 0 goes to 0, but it can't equal 0. So we do an open interval. And now let's go ahead and plot -2. The absolute value of -2. So you're doing absolute value of -2. That equals 2. So that goes there. And then you should know what absolute value looks like. And it's just a straight line like that. All right. So that's that portion from -2 to 0. Now at 0, we already know that goes to 1. So that's a point. And then we have to determine what's going on with all numbers greater than 0. So if you plug in 0, that's just 0. So that's another open circle, open interval there. And then you plug in 1. 1 maps to 1. And 2 maps to 8. So when you have a cube, you need 3 points. So we have the 0. 0 maps to 0, 1 maps to 1, and 2 maps to 8. Because you know if it's this, if it's not a line, it's going to be a curve. So we have a curve here. And then 3 would map to 27. So that would go up like that. So there's your graph. And what's happening here, remember condition 3 failed. Well, if we start here, it's continuous, but then we have to jump to this point. So this is called a point discontinuity. That's why condition 3 failed. So it's not continuous. Now we already stated the domain. The domain was -2 to 0. You could actually see it here. All right. Or you could just say x is greater than equal to -2, because you're going from left to right when you're doing the domain, starting from here and going to infinity. And for our range, see, our range is from -infinity. So it starts at -infinity. And we go up to 0. It can't equal 0. So we're going to put 0, but open interval there. And then it jumps up to 1. Okay, so, but no. So there's no 0. But then we can start at 0 again and it continues on. So then it's going to go 0 to infinity. Because even though there's a jump right in here, we still have y values right in here. So that's your range. And intercepts, we have none. Oh yeah, we do. We have this y-intercept right here. And that's your y-intercept, 0, 1. And the last bit, we just have to evaluate. And we pretty much already did this. If you plug in -2, that's absolute value of -2, which equals 2. You plug in 0, that goes with this middle portion, and that just equals 1. That's a point 0, 1. And then for the last one, for 2, 2 cubed equals 8. And that's it. Thank you. Have a nice day. Bye-bye.